Just kind of a high-level thing reflecting on how we should build software-based products and services in general. I know it's late. Some of you want to beat the traffic. If that's the case for you, the takeaways, the things that I'm going to speak about, so that you don't have to watch the rest of the presentation if you don't want to, not judging at all. Number one, we can apply the things that we're talking about, science, statistical analysis, data-driven stuff, to software delivery. And we haven't historically done that because you can't, it's very hard, let me say, to run randomized controlled experiments on software delivery teams because they're very complex, they're very sensitive to the variables. What you can do, though, is take a theory-based scientific approach to studying the way teams work, and that's what I'm going to talk about today. When you do that, it turns out that your performance at delivering software impacts organizational performance measures that you care about, both commercial and non-commercial measures. We've looked at the practices and capabilities that come out of the lean agile paradigm. We find that in most cases, they work and they drive software delivery performance. We also found a way to measure culture and the importance of culture, and we note that these practices impact culture, and culture impacts software delivery performance and organizational performance. But you have to take a holistic approach. You can't just do a little bit over here and expect other things to change. You're not going to be able to do A/B tests unless you can already do continuous delivery, for example. So even though we're, 17 years into Agile, in my experience, the most common Agile process I see on the ground, particularly in large organizations, but even in small organizations, is what Forrester used to call water, scrum, fall. And in this industry standard process, we still take weeks or months to come up with ideas for new products and go through the budgeting process and do tons of analysis and estimation and requirements gathering. And then some plan lands on some project manager's desk, and then the development team are working in nice iterations where they're doing analysis and development and testing in weeks or 2 weeks, but we're not delivering software to users at the end of this. You have to wait until the whole release is complete. That goes through QA, and then that goes to IT operations. So typically, that bit at the beginning, the fuzzy front end, and that bit at the end, the last mile, that can take over half of that entire lead time from idea, golf course, through to measurable customer outcome. And changing the middle bit to be agile doesn't typically have a huge impact on those overall lead times. You might see maybe a 5 or 10% increase or improvement in lead times, decrease or improvement in lead times by making the middle bit agile, but it's not going to have a huge impact. So who in this room maybe has a friend who works at a company that still operates in this kind of way? Right, so even in this conference, which is advanced class, frankly, there's still like a quarter to a third of you who are working in this kind of way. And so I think the important thing to bear in mind is it doesn't need to be like that. I still like to show this slide from 2011 from a presentation by someone from Amazon, from John Jenkins, where he talks about the fact that Amazon is releasing changes to production on average every 11.6 seconds. So this is just production. Up to 1,079 deployments in an hour. On average, 10,000 boxes receiving a deployment, up to 30,000 boxes receiving a deployment. Now, those are aggregate numbers across all the services that make up Amazon, but that's still incredibly impressive. And by the way, Amazon is highly regulated. They're a publicly traded company, which means they have to follow Sarbanes-Oxley. They process the occasional credit card transaction, which means they have to care about PCI DSS. So highly regulated, and yet they were able to achieve this. And they're at least one order of magnitude faster than this now. This is 2011. One of the things about Amazon is that as they get bigger, they also keep getting faster and more productive. So the reason they did this and they built this continuous delivery capability was not actually anything to do with experimentation. It was because they ran out of horizontal scale on their monolith, and they had to move to a service-oriented architecture just from a scale point of view. But what it enabled them to do is do A/B testing and do experiments in production. So we're very lucky to have Ronnie Kahavi here giving a talk starting off the day. And I love to show this quote, which I show all the time, from his paper on online experimentation at Microsoft, because before he was at Microsoft, he was at Amazon, ran their experimentation team there. And it's just always worth bearing in mind this quote. Evaluating well-designed and executed experiments that were designed to improve a key metric, only about 1/3 were successful at improving the key metric. So this is for a validated product where we've got product market fit and we're just adding features to that. And these are the odds that your good ideas will actually turn out to have a positive impact. Now, the odds are much lower if you're before you've hit product market fit or it's a new product or whatever. And this kills us. This is disastrous in 3 ways. If you're adding features that don't actually improve the business, there's the opportunity cost of adding a feature that would actually make things better. You have to maintain those features forever, and those features add complexity to your software systems, which slow down the rate at which you can add further features. So in my opinion, that's the biggest source of waste in software delivery, is building features that don't matter. But it's important to bear in mind, you can only even do this if you already have continuous delivery in place. So the one enables the other. So for the last 5 years, I've been studying high-performing organizations, trying to find out how you actually get to this place where you can, do what Amazon does. Maybe not be Amazon, but and there's certain parts of Amazon that aren't that great, frankly, as well. So it's not like Amazon's perfect, but have this capability. And I'm going to present some of those results today. So I'm not a statistician or a data scientist. All the statistics and data science was done by my co-founder of my startup and collaborator, Dr. Nicole Forsgren. So she's the lead investigator on this work. She has a PhD. She was a professor at Utah State. She also loves Diet Coke, which is why she's in Atlanta today and not here. So she and I and Gene Kim, in conjunction with Puppet Labs originally and now with Google, have been running a survey for the last 5 years called the State of DevOps Report. You can go and download the State of DevOps reports for the last 5 years from our website, devops-research.com. The most important result overall is that actually software delivery matters. So we've been told for years that software doesn't matter. This is Carr's Harvard Business Review article, IT doesn't matter. We found that's not true. We find that firms with high-performing IT were twice as likely to exceed these important commercial goals: productivity, market share, and profitability. So IT does matter. If you're better at delivering software, you achieve better commercial results. We also found a couple of years ago, or last year in fact, that software delivery matters for a bunch of non-commercial reasons that you care about, such as the quality of your products and services, your ability to achieve organizational and mission goals, customer satisfaction, and so forth. So this is important to all companies, not just commercial companies, but also if you're working in the government, as I was in 2016, or if you're working in non-profits or in the education sector or other mission-driven organizations. This stuff's still important. So the question that you should be thinking at this point, although it is still quite late, is how do we measure software delivery? Well, we found a valid and reliable way to measure software delivery performance that has been shown to be valid and reliable for the last 5 years that we've been doing this, and it includes 4 measures. There's 2 measures of throughput or speed. Lead time for changes, how long it takes you to get changes from version control into production, and then deploy frequency, how frequently you release stuff to users. And then 2 stability metrics, time to restore service. When you have an incident in production, how long does it take you to restore service? And change fail rate, when you push a change into production, what percentage of the time do you have to remediate, either by rolling backward or rolling forward, which is a measure of the quality of your release process. So these 4 measures we found valid and reliable. They predict those organizational outcomes that I talked about in the previous slides. So they matter and they're good measurements. If you take only one thing away from the next half an hour, it's this. High performers are not trading off throughput against stability. They're not moving faster and breaking things. They are getting better at both. So high performers do better at both throughput and stability. Low performers do badly at both throughput and stability. Going slowly does not make you safer. It makes you less safe. And just a very visceral way to think about that, there's huge problems at the moment with security and people hacking into websites. And much of that is caused often by unpatched software. And the question you've got to ask yourself is, when a vulnerability comes out, when there's a CVE announced, how quickly can you get all your software systems patched? That's a lead time problem. That's a question, A, can we identify all those bits of software, and then how quickly can we patch them and release that into production? So security is actually about speed and reliability and lead time, and it's about these things that we talk about. So not being able to move fast is actually an enormous problem from a security point of view and a stability and availability point of view, as again we found this year. So just to give put some numbers on that, this year we did some cluster analysis on our responses to the survey data, and we find there's 3 groups, and the high-performing group actually splits into a high and an elite-performing group. And we find the low-performing group is deploying, between once a week and once a month, and it takes them months to get changes into production from version control. It takes them a really long time to restore service in the event of an incident, between 1 week and 1 month, which is pretty terrifying, and their change fail rate is really high. On the other hand, elite performers are deploying multiple times a day. It takes them less than an hour to get changes into production. And crucially, if there's some kind of outage or incident, they can restore service in less than an hour as well, because they can use their regular change process to make emergency changes. One of the questions I like to ask is, do you have an emergency change process that's different from your normal change process? So who has the special emergency change process? All right, what don't you do in the emergency process that you do in your normal process much more of? Testing. How good an idea is it when your production system is broken not to test the fix you're about to put in place? Might not be a great idea. So one of the goals is to be able to use your normal change management process for emergency changes because it's really robust and reliable. And then we see that those people have higher change fail rates as well. So the capabilities that I'm going to talk about are important because they improve speed and stability and quality all at the same time. We're not making trade-offs here. We're changing the game and improving along all these different axes. In terms of the people who responded this year, we actually find that a larger proportion of our respondents are in the higher performing group than previously, and that's good because that means the industry is actually getting better at this stuff. So that's the percentage of the people who responded to our survey who were in the various different groups. And so 7% of the overall total were in this new elite performing group that came out of our cluster analysis. And again, that elite performing group is also able to optimize for both throughput and stability. This year, in the 2018 report, again, you can go to this URL, bit.ly/2018-devops-report, and download the 2018 report. We also looked at availability. Availability being the ability for teams to ensure that users can access their product and that they can make promises that they can keep about their availability. So by adding availability to those measures I just talked about, we've got a complete picture of the whole software delivery lifecycle from development all the way through to release into operations. And we find the same thing again. People are not trading off availability against those other goals. We find that elite performers are 3.5 times more likely to also have strong availability practices. So people who are doing well on speed and stability are also doing well on availability as well. So having looked at these outcomes that we care about from our software delivery process, obviously we want to understand, how do we get better? How do we improve our software delivery capabilities and get better at speed, stability, and availability? So over the last 5 years, we've been looking at this in some detail. You probably can't read this at the back. I'm sorry about that. But I'm going to go over this in more detail, so don't worry too much. All this is in this book, Accelerate, that we put out this year. Just some key things I'll point out. So software delivery performance is this box here, which predicts organizational performance here. These are all the things which predict software delivery performance. So there's a bunch of technical stuff, which is broadly speaking the capabilities that continuous delivery talks about, things like test and deployment automation, trunk-based development, continuous integration, comprehensive use of version control, and some other things like effective monitoring and observability, what else? Building security in the software delivery process, and architecture, which I'll talk about in a little bit more detail later. We also have a bunch of lean management practices, things like limiting work in process, visual displays for management, and feedback from production into our decision-making process, from our monitoring and our experiments, and then some lean product development stuff, which again, I'll go into more detail on. The important thing is all these things impact software delivery performance. They also impact culture. So I'm going to talk about culture right at the end. But as I say, you can measure culture. And in our research, we showed that implementing these practices improves your culture. And your culture, in turn, predicts your software delivery performance and your organizational performance. These lean product development capabilities also directly impact your organizational performance. And there's kind of a virtuous circle whereby improving software delivery performance, like being able to do continuous delivery, also impacts your ability to implement these lean product development practices as well. So as you get better at delivery, that improves your ability to do lean products practices, and that in turn improves your ability to deliver more stuff. So there's an interesting virtuous circle there. So just a quick dive into the technical practices. I'm not going to spend too much time on this. As I say, mainly the practices that we talk about when we talk about continuous delivery and continuous integration. This year, we also looked at the impact of cloud infrastructure done right, so where developers are able to self-service stuff rather than having to raise tickets in ServiceNow and wait weeks for their cloud infrastructure to be provisioned. So doing cloud infrastructure right also impacts software delivery performance and availability. These practices also reduce deployment pain, the extent to which people experience deployment as painful, and they also reduce burnout as well. So we measure team burnout, and we find that implementing these technical practices reduces team burnout and positively impacts culture. One thing I want to spend a little bit of time on briefly is architecture. So there's been some discussion of architecture and moving to service-oriented architectures today, and I think that's really important. A lot of people focus on the tools, things like Kubernetes and Docker and the various tools that you can use to move to microservices. What we found is actually you can do continuous delivery with mainframe systems, and you can have the latest WYSI Kubernetes microservice architecture and totally fail to do continuous delivery. So what's important as you're implementing these practices and these tools is the outcomes that you're trying to achieve. What we found is in last year's survey, the biggest predictor of continuous delivery was whether people could answer yes to these 5 questions. Can my team make large-scale changes to the design of its system without the permission of someone outside the team or depending on other teams? Can my team complete its work without needing fine-grained communication and coordination with people outside the team? Can my team deploy and release its product or service on demand independently of other services the product or service depends on? Can my team do most of its testing on demand without requiring an integrated test environment? And crucially, can my team perform deployments during normal business hours with negligible downtime? So that last question, for who in that room is that true, that you don't have to work evenings and weekends when deployments go out, or that no one has to work evenings and weekends when deployments go out? That's a pretty small number of hands. For whom in this room are people working evenings and weekends when deployments go out? So if you are working, or people in your organization are working evenings and weekends when deployment's out, put your hand up. Okay, that's like a fifth of people here. So that's a sign, that's not something anyone should accept. That's a sign that something's wrong that you need to fix. And I basically consider that a personal symptom of my personal failure, that we're still doing deployments at evenings and weekends in 2018. So as I say, you can have mainframes and do this stuff. You can have Kubernetes and not do this stuff. And what's important is actually the outcomes, not the particular tools that you're implementing. So as you're doing all this cool new stuff, keep the outcomes in mind, because that's actually what's really important. Briefly, I want to cover some of the lean management stuff. So what was interesting about this is, obviously we've all studied the lean thing. We know that having limits to work in process is important. What we found is actually, on its own, having effective WIP limits has no correlation with software delivery performance, which was mysterious. What we found is it's only when you combine that practice with the use of visual displays to monitor quality, productivity, and work in process, and the use of data from production to inform your decision-making process, only when you combine those practices do you actually see a statistically significant impact on software delivery performance and culture and lower levels of burnout. So you've got to combine those capabilities. They're no good on their own. You have to combine them in order for them to be effective. But when you do that, we do see an impact on those outcomes that you care about. And then I want to spend the rest of the time talking about product development, because obviously that's the main topic today. So historically, we've looked at these practices, working in small batches, which means taking your 1 month long thing, splitting it into things that take a few days, pushing those out, getting feedback, rather than releasing things in big batches. And ideally getting out changes in really small increments that take just a few hours and pushing, an hour or a few hours worth of stuff into production in these really small batches. That's really the goal. Visual management, gathering, and that's things like having Kanban boards and stuff that people can actually see what's going on as work goes from idea to production. Gathering and implementing customer feedback. So a lot of people get feedback. A lot of people don't really act very effectively on the feedback from their customers. And then team experimentation, which means the ability of teams to actually influence what they're building. So it's still very common, as a couple of talks have talked about today, for development teams to be order taking, feature factories, taking orders from upstream, rather than actually being able to influence what it is they build, which is hugely problematic. So these practices together, again, we looked at them this year. We find that they predict software delivery performance, including availability, and they also positively impact culture. And in fact, they also directly impact organizational performance, which is profitability, productivity, market share, and then those non-commercial things like quality, customer satisfaction, the ability to reach mission goals. So this stuff works. It impacts your performance at both the software delivery level and the organizational level. But I just want to zoom in a little bit on what we mean by team experimentation. So we already talked about, John talked about feature factories and the problem with feature factories. And this whole thing today, really, a lot of it is about taking a hypothesis-driven approach to product development. Instead of requirements, you will build this because I say so. Here's some hypotheses. And I really like this template from Jeff Gothelf. We believe, instead of as a, I want, so that, yay. Instead of that, we believe that building this feature for these people will achieve this outcome. We'll know we're successful when we see some signal from the market. We're going to make some measurement and use that to decide whether our hypothesis is in fact true. So, I mean, and something important to bear in mind, not everything you build is going to be done in this way because, as we know, experimentation is complex and difficult to get right. And if you know you just need to fix something, you don't need to design an experiment to test that you need to fix a bug, right? Or some small feature for someone who asks for something. We're not going to be, religious about building everything in this way. But for the things which are bets, where we're going to invest a significant amount of effort, we should certainly be thinking in this kind of way. Who's heard of a tool called impact mapping? Okay, not many of you. Great. So I think a really great way to think about this, and also to change the culture of the kind of feature factory, is this very simple tool called impact mapping. So this guy, Gojko Adzik, wrote a very short book with lots of pictures, which is really nice to read, called Impact Mapping, but this is basically it. And the idea is you get the stakeholders in the room, so some developers, your product manager, the people who are going to benefit or prevent the feature from being delivered, and you think about what's the outcome we're trying to achieve. So you start building an impact map by everyone getting in a room, and then you're like, okay, what's the goal we're trying to achieve? What's the outcome? So you start with the outcome, and then you think about who are the people who could help that outcome being achieved or who could prevent that outcome being achieved. You can just put it up on a whiteboard with sticky notes. You can brainstorm it. Everyone can come up with the sticky notes. And then you think about how those people could help or prevent that outcome being achieved. And again, you can brainstorm this, get a bunch of sticky notes. And then finally, you think about what you could do to help or prevent that outcome being achieved. So you end up with this kind of nice map where there's a whole bunch of things we could do. This is an example from financial services. We're going to reduce the transaction cost of a trade by 10%. Here's the people who could help achieve that goal. Here's how they could do it. And then here at the end is the what. And the nice thing about this is someone talked earlier about this kind of vicious cycle or chicken and egg problem of not knowing what to build unless you know how much it's going to cost, and not knowing how much it's going to cost unless you know what it is. In this very collaborative process, you can then start having these discussions at a very high level of, which of these things is going to be cheap and which is going to give us the biggest impact, because you have all those people in the room, because that's how you start doing this stuff. You can start having these discussions. And the important thing to bear in mind is in the kind of old school agile process where we just give people, or order taking agile, which is not really agile, where we give people story cards and they do stuff. What's happened is that someone upstream, some analyst or product manager, probably in their head has picked a single path through this map and shipped like one path through this map. And then all the other possibilities to achieve this outcome disappear into their brain as they sleep, and no one ever hears about them. Right? So we've taken a beautiful image and compressed it down into a single pixel. And I think that's a big driver to the kind of feature factory thing, is that we haven't as a team all considered the various possibilities and how we can achieve the biggest impact with the smallest amount of work. So I think this is a great exercise for product managers to do, and as a team, with their team as a team. And I think it fits nicely into this model. You know, we believe that building this feature for these people will achieve this outcome. And then you can think of what's the experiment we're going to run to validate that, in fact, this feature will achieve this outcome. How are we going to measure that? And this is where user research comes in. So, I mean, it's important to bear in mind, there are so many different kinds of user research. This is a diagram from Janice Fraser, who is one of the co-founders of Luxor, which was acquired by Pivotal. And it divides user research up into quantitative and qualitative, both of which are important and complementary, and generative versus evaluative kinds of user research. And A/B testing, which is most of what we've been talking about today, is just one of those different ways of doing user research. And here's the thing, we're not going to do A/B testing for everything, but we should be doing user research for everything, absolutely everything that we build. And that could be something as simple as building a prototype and showing it to someone, doing some surveys, doing some hallway usability testing, all the way through to kind of more sophisticated anthropological techniques like contextual inquiry. But we should be doing the critical thing is do user research for everything you do. And, you know, A/B testing is very powerful because it gives you cause and effect relationships between building this feature and the business outcomes, which is amazing. You know, nothing else gives you that causal link between feature and business outcomes. So it is incredibly powerful, but it's also expensive. And you can't always do it because you need sufficient amounts of data. In order to do that, we actually need to have a culture of experimentation. And again, this year we looked at one of the other ways to develop culture is by giving teams autonomy. And when leaders give autonomy to their teams, people feel more able to speak up about things and people trust their organization more, and that causes them to speak up more. Those things impact culture, and autonomy impacts those software delivery performance outcomes that we care about. So I just want to briefly talk about culture. We measure culture in our studies using this model from a guy called Ron Westrom, who studied safety outcomes in healthcare and aviation. And if you look at this typology that Westrom created, you can probably see the kind of organization you work in, whether it's pathological, bureaucratic, or generative. How effectively do people cooperate with each other? Do we shoot people who bring us bad news, or do we train people to bring us bad news? Are responsibilities ignored because we know we're going to get into trouble if things go wrong, or do we share risks? Is bridging discouraged or encouraged? Does failure lead to you're fired, or does failure lead to how can we improve our system of work so that the next person in this situation doesn't have the same problems? And then how do we deal with novelty, which are two sides of the same coin? You know, in an organization where failure is punished, no one's going to innovate, because by definition, innovation is doing something that hasn't been done before. And if you're punished when things go wrong, you're not going to innovate, because chances are you'll do something new and it will go wrong and then you'll be punished. And I think the important thing to bear in mind is what we found is there are many ways to change culture. And the way to change culture is by implementing these practices. So by implementing continuous delivery, lean management, lean product development practices, those things all impact culture. So you shift culture by changing people's behavior. And you change people's behavior by implementing practices and capabilities. And that requires support from leadership, again, which we talk about in the book, but I don't have time to cover now. So culture is important. It's measurable. You can measure it on a likert type scale in a survey. Just give people a number from 1 to 7 and get a score for it and average it across your organization. And it can be changed. And I'm just going to end up with a story from Amazon that I really like from the early days. So there's a guy called Greg Linden who worked on Amazon's checkout. And this is a story that was published in 2006. So it happened sometime before that. I don't know exactly when. And he talks about how he built this feature which was customized recommendations for checkout. So, you know, someone else, Brett, bought a bunch of things, and I bought some of the things that Brett bought, and so the recommendations engine is going to recommend the other things that Brett bought that I didn't buy when you click to check out on Amazon. So he builds a prototype, and he goes up to the VP of products for his division at Amazon and shows the VP of product the prototype, and the VP of product says, that's a terrible idea, you should not build this, it will distract people from checking out. So Greg is a little bit sad, goes back to his desk, takes his prototype, brushes it up a bit, pushes it into production, gathers a bunch of data from production, which demonstrates that actually this feature significantly improves conversion, goes back to the VP of product, who's probably not that happy, but doesn't in fact fire Greg and says, you should go and build this. This is obviously an important feature. Greg goes and builds it, and even today when you check out on Amazon, you get recommendations. So who in this room works at an organization where against the express instructions of a VP, you could still deploy something into production and not get into trouble? A few of you, like maybe 25% of you. So this is in 2006. And this goes back to the nice diagram John Cutler showed about trust earlier on today. But he ends his blog post, and I'm going to end my talk with this quote, which I really like. I think building this culture is the key to innovation. Creativity must flow from everywhere. Whether you're a summer intern or the CTO, any good idea must be able to see an objective test, preferably a test that exposes the idea to real customers. Everyone must be able to experiment, learn, and iterate. Thank you very much. If you want these slides and a bunch of other free stuff, thank you.